Step functions are not only used to step from one constant to another constant, but can be used much more general. We will encounter two possibilities in this video. We can use them to start a function later, or we can use them to shift the entire function. Let us see how this works and what exactly the differences are. So let's start with starting functions later. So what can we do? Suppose we have some f of t which is 0 between 0 and 1 and then becomes e to the power t over 2. So here's a graph. So we start at 0 and after that if we are at 1, so over here we jump to e to the power t over 2. So I also dotted the e to the power t over 2 between 0 and 1, but that is just to show that the function actually starts here. The function is 0 on the first part and then starts as being e to the power t over 2. So here f of t is basically then u1 of t, so 0 between 0 and 1, and then starts to become g of t, which is e to the power t over 2. So that's one idea. So you have e to the power t over 2 everywhere, but then you say, okay, let's start it a bit later. Let's say we put the first part to 0, and we become only e to the power t over 2 if you are at t equals 1. So that's one idea. Much more frequently used is the second idea. We can have our e to the power t over 2, and we say we shift the entire function. So we start with 0 here, and then we have our e to the power 2 t over 2. We do not start later at a higher point. Now we start at a low point, and we just shift everything to t equals 1. So how do you do that? So it's in a similar way. So our h of t is again 0 for t between 0 and 1. And then we become e to the power, the shifted t time, e to the power t minus 1 over 2 if t is bigger equal to 1. So that's the second idea. So what do we have in that case? Again a u1 of t, but in this case we have a shifted g equals e to the power t over 2, and we have a shifted g, a g of t minus 1. So a u1 of t times g1 of t minus 1. So let's do some examples. First we shift a function. So what do we have over here? We have a sine of t. Okay, that's fine. The sine of t is everywhere. And then we have a cosine of t. And we say, okay, we shift our cosine to start at t equals pi over 4. And then we add it to our sine. So our f of t equals sine of t, okay, plus, and then the shifted cosine. So the cosine starts at 1 at t equals pi over 4. So we have our sine, we have our cosine, but we shift the cosine to start a bit later. That is how we can use shifted functions. Starting functions later is a bit, works a bit differently. What you can do then is you say, okay, I have my sine of t. The sine of t is everywhere. But now I say I want to start adding a cosine at t equals pi over 4, but I do not want to shift it. I just want to start the cosine at t equals pi over 4. So it starts at its value 1/2 square root of 2 in this case. And in that case you have sine of t plus an unshifted cosine. Okay, that's what happens if you start functions later. Now actually you can rewrite this sometimes as some shifted function, as we will see over here. Note we can do the following. So this cosine t, we like to write it as some function of t minus pi over 4. And that is possible in this case. Because the cosine of t equals cosine of t minus pi over 4 plus pi over 4. So this sum is 0, of course. And then we can use the formula we know for cosines. Cosine of a plus b equals cos a cos b minus sine a sine b. So that's what we do over here. Cosine minus sine. And this cosine pi over 4, which is 1/2 square root of 2. And sine pi over 4 as well, also 1/2 square root over 2. So now we can rewrite our g of t, which was sine pi plus u pi for cosine t, as the sine still, plus some shifted functions, the cosine and the sine. So So even in this case, we can also view this function which started later as some shifted functions. And actually, shifted functions, that is what we will use much later, as we will see in some upcoming videos.